I'm not going to stamp them this minute, but just to give you a notice, all 12 of those should be done. Okay. Number 10. This is a circle. How can you tell that something is a circle? It has x squared and y squared in it. And the center is the locator point, which is -1, -4. And then the radius is 3 again. Apparently, we're just not that creative on these problems. And voila. That is a great warm up right there. I feel warmed up now. All warm. Okay. Now, next one, number 12, is a sleeping parabola. How can you tell it's a sleeping parabola and not a regular parabola? Yeah, it's x equals, not y equals. Okay. So, and this one does not have an a value of 1. So we actually have to do some work. No. Okay, so the vertex is H is on the outside for our sleeping parabolas, and K is the switch sign of in the parentheses. So 6, -3. Okay, and then A is -2. We're actually going to make a table. This is going to be really strange though, and I need you to grasp what we're going to do here. So 6, -3. Put the vertex in the middle of the table. Okay. Now, do you see how it's x equals and not y equals? Okay. What you want to do for your table is you want to go 2 up on the y and 2 down on the y. That way you can plug these in for y to get the x. Okay, so let me say that again. For sleeping parabola, when you want to make the table, you put the vertex in the middle and then go up and down on the y's, not the x's, because you want to be able to plug it in. Okay, so what's -5 plus 3? -2. What's -2 squared? 4. 4 times -2, -8 plus 6. Okay, -4 plus 3. -1 squared. 1. 1 times -2. -2 plus 6. 4. Okay, now question, are these going to be symmetric? See if it makes sense. Yep. Okay, so at this moment, check over your warm-ups. All 12 of them should be done. Okay. Let's start the team test. Okay, everybody. So number 69 is a review of what we did on Friday. So this is a one variable inequality, which means that it's got an alligator in it and there's one variable in the problem. Okay. Looking at my steps, does anybody remember what step one was of a one variable inequality? It was kind of funny. I was trying to be funny. Yeah, pretend you have equals. Okay, so step one, that's easy. Everyone can do it. Pretend you have equals. Okay, now I want to pause here real quick. And I want to ask you a question about order of operations. Let's pretend that this was not the equation you had, but this was the equation you had. Oh, the back in the day when that was your math problem. Weren't those good times? Okay, now what would you do first if this was your math problem? Add 2, right. Okay, so that's going to be the same thing we do here. Okay, and then on this problem, after I added 2, what would I do? Divide by 4. Notice I would not try to distribute or anything crazy. Okay, now on number 5, on the day that you guys did whiteboards, we talked about how do you undo an absolute value. It was back on the whiteboard back here, but I covered it up with these amazing spider webs from my second period class. Aren't they great? So anyway, does anybody remember what I said? How do you undo an absolute value in an equation? Plus or minus. Thanks, Ben. So you go like this. No, don't go like that. Go like this. So undoing absolute value is plus or minus, just like when you square root both sides, same deal. Okay, step 1, pretend you have equals. Step 2, solve. Step 3 is the number line. Make sure that you've got the things in the proper order. So -3 goes on the left, 1 goes on the right. And then take a look back at the original problem, open or closed. Perfect. Okay, and then you have to pick something to test. The only things you can't test are -3 and 1. But I want to test 0 because I'm lazy, so I'm going to throw 0 in my number line. I don't actually know that 0 is the best choice. Does anybody know what the best choice is? Yeah, -1's the best choice, but I'm going to do 0 just because lazy. I mean, actually, -1 is also lazy. But whatever, just as long as it's not the 2 that have dots. Okay, so order of operations, 0 plus 1 is 1. Absolute value of 1 is 1. I tell my math one class, when you take the absolute value, it just turns into parentheses. And then you can see that it's multiplication. Okay, so really important thing I need you to know is anything that I plugged in between these two dots would be false. It doesn't matter what I plugged in. Everything in there would be false. -1 would be false. -2 would be false. -2.5 would be false. -2.9 repeating would be false. Everything in there would be false. So the solution set is everything else. Arrows out. And it would not matter what I plugged in here, that would be true. It would not matter what I plugged in here, it would be true. Anything would be true that I plugged in. Okay, final answer. X is less than -3, or X is greater than 1 with arrows going out, just like the arrows out picture. Okay, that problem was a review from Friday, except kind of not because we didn't do an absolute value one. Any questions about number 69 before I move on to number 70? Are you sure? Okay. Alrighty, now this one's different. So it looks very similar. It's got the same absolute value equation, kind of, except for I took the 6 away and replaced it with the y. So now you have an inequality with two variables. And I don't know if you guys remember these. These are the ones where you shade. So they're a lot less work, which is great because I don't like work and neither do you. Okay, guess what step 1 is? Yeah. Denial. Long river in Egypt. Step 1, pretend you have equals. Great. I can pretend y equals 4 times the absolute value of x plus 1 minus 2. Step 2, graph your equation, either dashed or solid. Dashed is open, solid is closed. Should this one be dashed or solid? Dashed. Okay, so how do we graph this? This is an absolute value, so it has a vertex at -1, -2. So absolute value has a vertex, -1, -2. And then absolute values, the A is the slope this is the part that I'm going to screw up. I'm going to screw it up anywhere. It's going to be that I have short-term memory loss and I'm going to make it solid, but it needs to be dashed. I remember a lot of times in high school, I have this vivid memory of erasing the solid lines like on a test to make it dashed. Do you know what I'm talking about? Yeah, a lot of memories of that. It must have been my weakness. It's still my weakness, but now I just say that I'm old. So I wasn't old then, it still happened, but whatever. Mm. Okay, step 3, test a point that's not on your problem's graph. What I mean by that is it's not already graphed on the V or whatever shape it is. So it's not dashed or solid already. Any other point will work. It just can't be on the thing because you want to know what side to shade. So you can't tell if you plug in something on the thing. What is a great choice? 0, 0. Okay, and I'm going to put a little circle there just as an indicator that that's the spot I'm going to test. What if the graph goes through 0, 0? What might not be another nice option? 1, 0, 1, 1. Those are my other two backups. Typically, one of those three is available. Okay, so put it back into the original. 0 is greater than 4 times the absolute value of 0 plus 1 minus 2. We already tested this side with 0 earlier. That came out to be 2. Okay, now this is really important that you guys see that there are two regions of this graph, the outside of the V and the inside of the V. Can you guys tell that the picture is split up into two pieces, the outside and the inside? Where we plugged in is false. That means any coordinate that I plugged in all the way to infinity will be false in this section. So I want to shade the true section, which is going to be on the other side. Any point that I plugged in from there would be true. Any point that I plugged in from here would be false. So the solution set is all the ones that actually work, which is a true section. My favorite thing about these is there's no final answer. Like there's no algebra final answer. The graph is the answer. So amazing. Okay. Any questions from number 70 before we do 71? 71's the last one already. I know. It's amazing. And also we're going to cheat. So if you could get out your cheating device or go grab one. Oh, camera difficulties. It's the wrong color, by the way. It said blue. No, it didn't. I have two purples? What the heck? What is happening? Yes. Yep, that's pretty much it. Okay. So you have two parabolas here. One of them is solid, one is dashed. I hope you can see that. And this is the one, you've already done this, but basically you're finding the overlap of the shading. So I'm going to treat these two like two separate problems, which is why I'm going to do them in two different colors. Is it necessary to do them in two different colors? No. Is it more fun? Absolutely. Okay, what I want you guys to do is practice your cheating, and I want you to get some coordinates for graphing each of these. We're going to go -4. For that one. Okay, so I want you guys to take a few minutes, go on the graphing calculator, and get the y values for these off of the table. Need to practice cheating. Okay, I'm gonna work on the blue one first. I'm gonna treat these like two separate problems. So I'm gonna do all of the information that I need for the blue one, and then I'm gonna do the pink one. So first thing I'm going to do is graph these. Hmm, I don't like it when the dots aren't symmetric like that. Solid. Okay, now the next question I have is 0, 0 clear enough where it's either inside or outside the parabola? I think so. Can you guys tell that it's inside? Okay, so 0 is greater than or equal to 2 times 0 squared plus 5 times 0 minus 3. Zero is greater than or equal to -3. True. Okay. What do I do if it's true? Do I shade inside or outside the parabola? Inside, right. So it's true there. That means it's going to be true anywhere in here. Okay, so that problem is halfway done now because I graphed it, checked to make sure it was solid, tested the point, shaded. Okay, now I'm going to switch to the other parabola, and I just have to remember that it's dashed. If I can remember it's dashed, I feel like I have a shot. 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay, is 0, 0 okay to test on this one? Correct, it's outside this time, but yes, I'm just gonna recircle this with pink so I'm only looking at the pink stuff. Okay, got true again. Do I shade inside the parabola or outside? Outside, which is bad news because I'm too lazy. Okay, now the final answer for this is the double shaded region. So I'm going to give you two pieces of advice. The graph is the answer, but you need to make it clear where the double shaded region is for your teacher when grading. So you need to make sure that it looks darker and covered by both things. If you have two colors, it makes it easier, but just make sure it looks darker on your test or quiz, just to make sure that I know what the double shaded region is. Also, second thing, extremely important. Do you guys know how like I use that software program to make our worksheets called CUDA? You know about CUDA? Okay, like the review assignment and stuff is all CUDA. CUDA, when they do the answer page, you know, like I'll put the answer sheet on with all the answers. They only shade the double shaded region. They're not gonna have two light shaded and a dark shaded. They're only like this picture for CUDA would just have the two parabolas, one solid, one dashed, and then only this part would be shaded. So you have to make sure when you're looking at that, your expectations are they're only gonna shade the double shade. It's not that you're wrong, it's just that they don't do that. Because the final answer is the double shaded. Okay, now take a look at the stamp sheet side, please. Tell me, what do I need to stamp? Okay, so where did I leave off here? So I need to do this, this, and this. This is tonight's homework, just 3 problems tonight, 82, 83, 86. And then the war. I did not do these. The scavenger hunt and the mid chapter. Okay, and then the warm up. So, I mean, I'll do my best to get around, everybody.